This topic is called the Pythagorean Theorem. A theorem is usually just like a rule that you need to use or can use, and the Pythagorean Theorem is all about right triangles. Right triangles can face different directions, but they all, no matter which way they're facing or which way they show up on your paper, we can recognize a right triangle because of this symbol. That little kind of makes a box now in that corner. That tells us that it's 90 degrees. And that's what makes a right triangle. A right angle makes a right triangle, which is a 90-degree angle. So we also need to figure out the vocabulary or learn the vocabulary around right triangles. You might already know this, but just in case, the side that is opposite that right angle, that is called the hypotenuse. And the other two sides are called the legs. And you don't have to differentiate one from the other. They're just both called legs. That doesn't, just because they're both called legs, doesn't mean they're going to have the same measure. They can be the same length, but generally they're not. So Pythagorean, I'm not going to go into the history of where it came from, but basically what the Pythagorean theorem is this. It's legs squared. If we take the measure or the length of the leg and we square it, and we add it to the other length, the other leg squared, it has to equal that side that's called the hypotenuse, that measure squared. So that's kind of nifty, because if we think something's a right triangle and it doesn't have this angle measure at the top or wherever it is, we're just guessing. We don't know that it's a right triangle. So this is how we can verify it if we have the three side measures. Usually a lot of math books and a lot of math teachers teach it this way. I really don't like using A, B, and C. It doesn't emphasize the fact that it's the hypotenuse that has to be the C value. A lot of kids that I've taught in the past don't get that when they're taught A squared plus B squared equals C squared. They don't know which side goes where. And the other thing is sometimes I've seen textbooks where they teach A squared plus B squared plus C squared, but then they're going to integrate some algebra into it, and instead of using X's and Y's, they use A's, B's, and C's, which makes it even more confusing because they're not even in the right spot. So if I teach it, I'm going to use this, I'm going to stick with it, and I'm not going to apologize for it. Okay, so let us do one of these here, and let's see. Okay, so how can we use the Pythagorean theorem? In general, the way that it's used, let's say that we have a right triangle, and we know it because we have the symbol there, and let's say that we knew that this here is going to be 6, and then this side here is 8, and we're looking for this. I'm just going to call it x. So as a first step, all you're going to do, which one's the hypotenuse? That's that. The hypotenuse is the one opposite the right angle. The other two are the legs. So if we say that it's going to be leg squared plus leg squared equals hypotenuse squared, we're just going to plug our numbers in now. The first leg, it doesn't matter if you use the 8 or the 6 because the order won't matter in this case. So we're going to do that leg's 8 squared plus the other leg here is 6 squared, and we're going to call that x squared, so we'll just leave it there. Whenever you have an x in an equation, you want to isolate it. It pretty much already is isolated. We're just going to have to get rid of this squared in a few minutes. Order of operations says that we square the 8 before we do any addition. So 8 times 8 is 64. The 6 times 6 gives us 36. And that equals x squared. And then order of operations says there's only one thing left to do. So when we add these two together, we get 100. And how do we undo an x squared? Well, the answer to that is we square root. If we're square rooting that side, we have to square root this side. And so what comes out of the square root of x squared is the plain x. And the square root of 100, they're basically asking you what times itself gives you 100, and the only number times itself is 10 that will give you 100, because 10 times 10 is 100. So now we've just found the measure of that hypotenuse. I'm going to do another example next, and that is going to it's going to be just a little bit different, but it's also going to be very much the same. So let me scroll that up. And let's see, so this time let's say that we have this right triangle. And let's say this time this is 11, and we'll let this side here be, I don't know, 7. How does that sound? Again, when I see a right triangle, one of the first things I think of is leg squared plus leg squared, equals hypotenuse squared. And sometimes it helps us, if you're new with this, to label the sides. Here's our right angle right here. So that means that this guy here is a hypotenuse, this guy here is a leg, this guy here is a leg. And I'm going to make that x because that's what we're looking for. So let's plug in what we have. For one of our legs, Doesn't matter which one we use, I'll use the 7. Our other leg we've labeled x, and our hypotenuse we've labeled the 11. So 7 times 7 is 7 squared, that's 49, plus x squared, and 11 times 11 is 121. So a minute ago in the last example I said whenever we have an x in an equation, we need to get it by itself. So if we think of this as the two different sides of the equation, I need to remove the 49. The 49 is positive, or it's being added, whichever way you want to look at it. So to bring it to the other side, so it's hanging out with the 121, I have to undo that positivity or undo the adding. So I'm going to subtract it. Alright, so 49 minus 49 goes away. That's what I wanted. I wanted just the x squared on this side. And then let's see, 121 minus 49, let's do a little borrowing. 11 minus 9 is 2, and 11 minus 4 is 72. And again, same as before, this last step will almost always be the same for the Pythagorean theorem. The only way to undo an x squared is to square root it. And x is going to equal the square root of 72. And you can just, like, that doesn't feel like a solid number. Like, how do you actually use that? So what you can do is just type it into your calculator, and let's see what I get here. Square root, and then 72, and that would be 8.5. So x is approximately 8.5, 8.485 if you want to get technical. But that's how Pythagorean theorem works. And again, if you can just label up your triangle with the hypotenuse and legs, write out your formula, plug in the numbers you know, get the x by itself, and then square root your final answer, and you should be good to go. Hope this helped.